So now, good morning students, welcome back. Today we'll discuss Kirchhoff law from the chapter current electricity. Okay, so now let's start. See the numeric. So let's start. Kirchhoff current law. Okay, Kirchhoff first law is also said to be current law, junction law or nodes law. Kirchhoff first law. Actually, Kirchhoff first law is related to current. That's what is called current law. We are having a lots of wire connected at a common point. This point is called junction. It is said to be junction or nodes. That's why Kirchhoff first law is also said to be junction law or nodes law. Okay. So now student, we'll start the first law, current law. It states that at junction, this is junction point. At the junction point, the algebraic sum of the current at nodes is always 0. It means at junction point O, sigma I will be 0. Sigma I means I1 plus I2 plus I3 till I equals 0. Incoming current will consider with positive sign and outgoing current will consider with negative sign. Means the current that coming towards nodes will take with positive sign and the leaving current will take with negative sign. So look, I1 is coming towards nodes, incoming, so plus I1. I2 is also coming towards nodes, so plus I2. See, I3 is also coming towards nodes, so plus I3. Incoming current will take with positive sign, while I4 and I5 is leaving current, outgoing current. So it will take minus I4, minus I5, and the sum will be 0 as per Kirchhoff first law. So entering current, incoming current will consider with positive sign, while negative current, while leaving current will take with negative sign. Okay. So minus I4 and minus I5 when we transfer, we'll get I1 plus I2 plus I3 equals to I4 and I5. It means we can define first law by one more term that sum of entering current is always equal to sum of leaving current. Okay, sum of entering current at nodes is always equal to sum of leaving current at nodes. That's why it is based on law of conservation of charge. Charge neither be created nor be destroyed. Total charge of an isolated system remains constant, same like total current remains constant. Entering current will always equal to leaving current. This is Kirchhoff first law, and this is related to current, related to nodes or junction. That's what is called current law, junction or nodes law. Okay, students. Now, students, we'll discuss Kirchhoff second law. Okay, Kirchhoff second law is applicable for closed circuit. Closed circuit. What is the meaning of closed circuit? When switch is on, when key is on, current is flowing in circuit. This circuit is said to be closed circuit, and closed circuit is said to be loop. That's why Kirchhoff second law is also known as loop law. It is related to potential. That's why it is voltage. That's why it is also said to be voltage law. Loop law, voltage law. Okay. Now see the statement. It states that the algebraic sum, okay, of change in potential. The algebraic sum of change in potential over a closed circuit, over a closed network is always 0. Sigma delta V equals to 0. Algebraic sum of potential of a closed circuit, change in potential of a closed circuit is always 0. Either we can define in one more term. See, another statement, alternative statement, algebraic sum of the EMF of cell, algebraic sum of EMF of cell over a closed network, over a closed circuit is equals to the algebraic sum of the product of current and resistance of that closed network. It means sigma E equals to sigma IR. This is Kirchhoff's second law. It is related to potential, voltage. That's what is called voltage law. Mainly, it is applicable only for closed circuit, and closed circuit is called loop. That's what is also said to be loop law. The important thing, the laws. Okay. Now I'm going to explain in which way we can apply the Kirchhoff second law with an example. Circuit. Look, students. We have taken a closed circuit. Okay. having cell E1, resistance R1, resistance R3, resistance R2 and cell E2. Okay. Look at friends, this E1 cell, when switch is on, it flows current I1. Okay. And when this cell is on, it flows current I2. E1 gives I1 current and E2 provides I2. Okay. This is I2. From upwards I1 is coming and from this E2, from downwards I2 is coming. Both will add at this junction and enters as I1 plus I2 in this wire. Current always completes its circuit from positive terminals to negative. So I1 will complete circuit like this and I2 will complete circuit like this. At this point again it will divide in two parts. I1 is coming from upwards, so it will move towards to upwards, okay, while I2 will move in downward direction and it's completed its circuit. So I1 completes its circuit while I2 completes that circuit. Okay. Now since we are asking find the value of I1 and I2 in such diagram. So how can you find? By applying Kirchhoff's second law, loop law. First of all I am going to apply loop law. In which loop? A, B, C, D, A. A, B, C, D, A. I'm going to apply Kirchhoff's second law loop law for getting the current, the amount of current. A, B, C, D, A. Look students, like this. So we'll start with positive terminals and end with negative terminals. Look at, I'm going to start here. The resistance is R1 and its current is I1. So there comes I1 R1. Okay, current multiplied with resistance. On account of that, sigma E equals to sigma IR. Current into resistance. Then come at that side. We'll complete our circuit. Look, we are moving in that direction. In this direction, resistance R3 and current I1 plus I2. So R3 multiply I1 plus I2. Okay. And will come on that negative terminals. There is no resistance. Simply current multiply with resistance. Okay. As per will write sigma E equals sigma IR. EMF of cell is what? E1. So in equivalent will write E1. Okay. We can arrange this equation as E1 equals to I1 R1, I1 R3 plus I2 R3. Equation number first. Okay. Now students, see, I'm applying Kirchhoff's second law in this loop. E, B, C, F, E. In this loop, okay. In loop E, B, C, F, E. E, B, C, F, E. I'm going to start here. I'm just explaining how to apply second law for getting the amount of current. Okay. So when we start with positive terminals, okay, and we have to come at negative. So we start from that side. The first resistance is R2 and its current I2. So I2 R2 current multiply with its resistance. Now come at that side. We are moving this in this direction and current also in same. That's why they come plus sign. Okay. Resistance R3 and current I1 plus I2. So write R3 into I1 plus I2. Okay. Now will come on negative sign. There is no resistance and EMF of this cell E2. So in equivalent will write E2. Again we'll arrange this I2 R2 R3 I1 plus R3 I2. Equation number second. Okay students. So we got two equations. We are having two variables I1 I2. So we made two equations. If we are having three variables I1 I2 I3, in that condition we have to make three equations. Number of variables equals to number of equations. Now students, if we are given the value of R1 R2 R1 R3 and R2, and if we are having E1 E2, by solving first and second equation we can get the amount of I1 and I2. I will give you the example of numerical also. This is simple, a basic example how we can apply Kirchhoff's second law in any circuit for getting the amount of current. This is just an example. Okay, if we are having the value of R1, R2, R3, okay, and EMF E2 and E1, by putting and by the solving first and second equation, we can get the value of I1 and I2. So that is the basic rules. Now students, one important rule is there. Okay, I'm going to apply loop law. In loop, A, E, F, D, A. Loop A, E, F, D, A. Look, A, E, F, D, A. Why? Because there comes an important rule. Look students, we'll start from here, from cell E1. First current I1 and resistance R1. So we'll write I1, R1. Okay students? We are moving downwards because we will not include this circuit. We are moving downwards. Okay? We are moving downwards, and look, current is coming from downward direction. R direction, this is R direction. Okay? And this is the direction of current. We are moving downwards, but current is coming upwards. R direction and direction of current is opposite. That's why we'll use minus sign. That is an important rule. Okay, that is one of the most important rule, that if R direction and direction of current is opposite, we'll use minus sign. Resistance R2, current I2. So minus I2 R2. Okay, now students, we'll move like that. There is no resistance, and again will come E1. Okay, and there is, in this complete circuit, we are having two cells. So we'll take their difference, E1 minus E2. We'll start from E1, that's why we did E1 minus E2. If we'll start E2, then we'll write E2 minus E1. But here we'll start it from E1, that's why we have written here E1 minus E2. So this is the final equation, third. Before that we made two equations. Now we can make third equation by this. I explain this equation for getting this important, for the explanation of important rule, this minus sign. Actually, when we complete the circuit, and if R direction, suppose we are moving here downwards from B to E, we are moving downwards, and this current is coming upwards. R direction and direction of current is opposite. That's why we use the minus sign. Okay, so here we write minus sign, current I2, resistance R2. So we write minus I2 R2. In this way you can apply Kirchhoff second law, loop law, in any circuit, and we can get the amount of current I1 and I2. If I3 is there, I3 also. Now students, I'm going to explain a numerical based on Kirchhoff law. Okay, a basic question. Look, we are given a circuit having cell E1 as 2 volt, E2 as 1 volt, and E3 as 4 volt. And we are given resistance correspondence with it 4 ohm, 3 ohm, and 2 ohm. And we are given the amount of current that E3 is providing I1 current. Okay, E3 is I3. At this junction, I3 will divide in two parts. In E2 will assume as I2. In E1 will assume as I1. We can also take I and I1 and I2. Okay, we took I3 that divided in two parts, I2 and I1. I1 come from that side, I2 is coming from this side. Again, both will add at this point, and here the current will come as I3. So I3 completes its circuit by two different ways, positive terminals to negative. Now he is asking to find the amount of current I1, I2 and I3. So we have to find these all current I1, I2 and I3 using Kirchhoff law. So I am going to apply Kirchhoff second law, that is called loop law, as well as I also apply the first law. Look at it, first of all I am going to apply Kirchhoff's first law. Kirchhoff's first law is also said to be junction law. At which junction? At this point I3 divided in two parts, I1 and I2. So I3 should equals to I1 plus I2. Equation number first. Sum of entering current into sum of leaving. I3 is entering and I2 and I1 is leaving. Sum of entering current equals sum of leaving current. Now students, I am going to apply second law, Kirchhoff second law, that is said to be loop law. In which loop? Look, in this upper loop. We'll give the name as A, B, C, D, E, F. So I'm going to apply Kirchhoff's second law, loop law, in loop A, B, C, D, A. A, B, C, D, A. We'll start with positive terminals and end at negative terminals. Okay, so let's start. Look, the resistance is 3 ohm and its current I2. 3 into I2. Current multiplied with its resistance. Okay. Look, we are moving in this direction. We are completing circuit in this direction, and current is coming from opposite. If our direction and direction of current is opposite, then we'll use minus sign. That is an important point. So I'm going to use minus sign for resistance into current. 4 into I1, and again come at negative terminals. No resistance is there now. So now students, in equivalent, on account of this, sigma E equals to sigma IR. On account of this, sigma E equals sigma IR. Current into this sigma IR will equals to sigma E. So we are having two cells. We started from E1, okay, and at E2. So we'll take their difference. And we'll write E1 minus E2. E1 is 2 volt, okay. So we'll take the difference as E1 minus E2. 2 minus 1. If we started from E2, then we'll take E2 minus E1. We'll always take the difference of potential from where we started to another. We started from E1, so that's why E1 minus E2. If we started from E2, then we'll write E2 minus E1. Now students, solve this. 3I2 minus 4I1, 2 minus 1, 1. Equation second. Now finally, I'm going to apply Kirchhoff second law, loop law, in this loop. Okay. E, B, C, F, E. E, B, C, F, E by loop law. So we'll start from positive terminals to negative. Okay, so we'll start here. First, resistance 3, current I2. 3 into I2. Current multiplied with its resistance. Okay. Now come at that side. Okay. Current is I3, resistance 2. 2 into I3 and equals. Again we'll come negative terminals. There is no resistance. We have written these two resistance. Now students, we started like this from E3 to E2. So we'll write 4 minus 1. We started from E3. That's why we'll write 4 minus 1. We'll take their difference. 4 minus 1. We'll have 3I2 plus 2I3. 4 minus 1, 3. Now students, we have to solve first, second and third equation. That will give the amount of current I1, I2 and I3. Okay. So what we'll do students, I'm going to solve second and third, but before that I will make one change. Okay. This is I3. In equation second we are having I1 and I2. So I will convert first of all this third also in terms of 1 and 2. So I'm going to put the value of I3 here from equation first. From first and third. Look students. See the third equation. 3I2. I am going to write 3I2. Okay. Plus 2 I3. What is I3? I3 is I1 plus I2. So I am going to write here I1 plus I2. Okay. And in equivalent there is 3. Okay. So I am going to write here 3. Now arrange it. 2I1, 2I2 or 3I2. It becomes 5I2 equals to 3. Give them as equation number 4. So now students, we will solve equation second and 4. Because second in terms of 1 and 2, 4 is also in terms of 1 and 2. Okay. So now from 2, I'm going to write equation 2 here. See the equation second. 3i2 minus 4i1 equals to 1. Okay. Now students, for solving this, we multiply equation 4 by 2. 2 2s are 4, it becomes 4i1. 5 2s are 10i2. 3 2s are 6. Okay, and this is minus 4i1 plus 3i2 equals to 1. Okay, on adding them, minus 4i1 2 plus 4i1 cancel out. 10 and 3, 13i2, 6 and 1, 7. For i2, we'll get 7 by 13 ampere. So we got I2. Okay students, first of all we got I2. And I2 when we put out of that 4 out of in these two, when we put I2 we'll get the value of I1. Now I'm going to put this value in equation number second. You can check from equation second. That was equation second. By this loop, 3i2 minus 4i1 equals 1. We made this. Put here I2 as 7 by 13. 7 3s are 21. Okay. Now students, transfer 21 by 13 that side. So 1 minus 21 by 13, it will come as minus 8 by 13. Minus 2 minus cancel out. 4 to 8 cancel out 2 times. So I1 will get as 2 by 13. And what was the final answer? I equals to I1 plus I2. So what was the I1? That is 2 by 13. What was the I2? 7 by 13. So it will come as 9 by 13 ampere. So total current will come as 9 by 30 ampere. In this way, by applying first and second law, we can get the amount of current. That was a basic question based on Kirchhoff law.